Julie Zimmerman. Dr. Zimmerman holds joint appointments as a professor in the Department of Chemical and Environmental Engineering and School of Forestry and Environmental Studies at Yale University. She also serves as the Senior Associate Dean for Academic Affairs at FES, as well as the Deputy Director of Center for Green Chemistry and Green Engineering at Yale. Her pioneering work established the fundamental framework for her field with her seminal publications on the 12 Principles of Green Engineering in 2003. Dr. Zimmerman is also the co-author of the textbook Environmental Engineering, Fundamentals, Sustainability, and Design, used throughout the world in the United States in our environmental engineering courses. In addition, Dr. Zimmerman is editor-in-chief for Environmental Science and Technology. Prior to coming to Yale University, Dr. Zimmerman was a program manager at the United States Environmental Protection Agency, where she established the National Sustainable Design Competition P3, People, Prosperity, and Planet. So please join me in welcoming Dr. Zimmerman.
Great. Thank you so much for the introduction. And for those of you following the P3 award, the 18th call for proposals just went out today. So hopefully you'll see that from the EPA and check it out. I'm going to talk to you a little bit about the convergence with COVID in terms of the impact healthcare has on the environment, and then talk about what a green chemistry future might look like with a neat example that we just launched a new company. So next slide, please. So the first thing to talk about is the impact of the healthcare sector globally. It's about 4.6% of the total greenhouse gas emissions. And you'll note the US is quite out of scope with other countries in terms of our emissions per healthcare treatment. Next slide, please. So interestingly enough, if healthcare were a country, it would rank 13th in the world for greenhouse gas emissions. So this presents a really a big opportunity, I would say, to bring engineering and chemistry to bear on how we provide healthcare and closes this loop on, we often think about climate change impacts on health, but this is really providing healthcare and the impacts on climate change. All of this data I'm presenting was before COVID. Okay, next slide, please. And if we dig into this data a little bit, there's lots of opportunities for engineers to get involved in terms of how we reduce the environmental impact of healthcare, whether it's thinking about buildings and architecture, how we do air exchange, airflow, travel associated with healthcare, and then looking, of course, at all the materials and chemicals. And we heard recently about PPE just a minute ago. Okay, so next slide. So just like thinking about how we reduce the environmental impact of the medical sector, we could think writ large about the chemical sector. And earlier this year, Science Magazine did an issue in their series on Tomorrow's Earth related to how do you design chemistry to match what we want for tomorrow's Earth. And so there was resulting paper of that is what I'm going to present now. So next slide. So if we think about the existing chemical sector, it looks a lot like this. We've heard already about linear flows of taking resources that tend to be fossil fuels and putting them through a very linear system, generating waste both at production and post-consumer use. We could also dig in and look at the kinds of chemistry that we're doing and the kinds of chemical engineering processes, and often the reliance on environmental engineers to clean up the landfills and impacts from incineration and emissions to water and air as a result of this process. Next slide. The other thing we note, of course, is the fence line community impacts of these chemicals and the way the current chemical sector operates. And so there's an opportunity to think about tomorrow's chemical sector to not only address these broad scale environmental impacts and public health concerns, but really these local environmental injustices. Next slide, please. So the article goes into quite detailed description of what tomorrow's chemical sector could look like. Most immediately, you'll note it's moving from a linear process to one that's more circular. and in a thoughtful way. And I'm going to talk about that in a minute as this push towards circular economy has emerged in our field. What does that really look like as we operationalize it? And if you dig into some of the underlying attributes of this new chemical sector, it talks about using renewable feedstocks, things that are non-toxic, using biomimicry to inform how we do chemical transformations, and changing our definition of what functional performance means to include sustainability as well. So next slide. So this is our latest company that we've launched out of the Center for Green Chemistry and Green Engineering. It's called Air Company. So this is a catalyst that we've patented and licensed to this company. The student who is leading this research is actually the CTO associated with the company, and it takes carbon dioxide, reacting it in sunlight with water over this catalyst to produce vodka, ethanol. Ethanol, as Kostas talked about, of course, is one of the options in how we move towards renewable fuel. But the economics of ethanol for fuel are quite hard to overcome, but people will pay $70 or $80 for a liter of vodka. So this is where the company started. Next slide, though. So this short video will tell you as the company has evolved. So for 6 months, we have produced vodka, and actually during that time from March through July, the company is based in the Brooklyn Navy Yard, actually switched to producing hand sanitizer to address some of the shortages around New York City for healthcare workers. They're back to producing vodka, and if you remember that fence line community that I showed you, this is actually where the chemical plant is located. And so you'll see it's a green space. There's lots of people around. The community that surrounds this looks really different. And if we think about solving environmental injustices, now we're talking about local economic development. We're actually talking about, instead of people fighting NIMBY, not in my backyard, for chemical plants, to put chemical plants in my community. It creates a tax base, it creates jobs, and it's actually not harmful for public health or the environment. That video that went by was the company just received a really recent contract from NASA to take CO2 and make rocket fuel and other molecules that are relevant if we think about long-term space travel. So if we can take carbon dioxide to ethanol, we can make plastics, we can make building materials, and change this world towards something that's more carbon negative using green chemistry and green engineering. So next slide. So I'm going to just talk you through a little bit about the flow here in terms of how we think about designing a green chemistry future. So the first one is function has to be at the heart and center of what we do. If what we make doesn't do what it's supposed to do, whether it's an adhesive or a paint or a water treatment technology, we're not going to succeed no matter how sustainable it is. The next question we would ask is it made from depleting resources? So if we're relying on fossil fuels, we can't get long-term sustainability from this. We need to move to renewable feedstocks. This includes bio-based feedstocks as well as waste feedstocks, such as carbon dioxide or cellulose and lignin, chitin, other vastly wide available waste materials from industrial processing. Okay, next is to then talk about the toxicity. What is the inherent nature of the chemicals, materials we're making, as well as the transformation or processing we're using to create those products and materials? How do we move towards things that are more benign, inherently safer, so we're less concerned about controlling the circumstances in which these things are utilized? Again, this benefits a public health perspective and addresses environmental injustice. And then finally, the next thing to think about is this idea and this giant push towards the circular economy. But as you really start to dig into this and start thinking about it, there are lots of things that we make, and we know as environmental engineers wind up in wastewater treatment plants that are never going to come back into a circular economy, whether it's shampoo, pesticides. These things are distributed in the environment and are intended to be so. And so we actually want to think whether these things should be made to be degradable versus those things that we want to design to be persistent because they have high molecular complexity or because they have high embedded energy. And therefore, it makes sense to try to close the loop on those materials versus things that we should not be chasing to bring into a circular economy. So next slide, and it's my last slide, is the difference between the compass and the speedometer. And I know I've laid out quite a bold vision and some big goals, but big opportunities for this community. And I would just remind all of us that the most important thing is to orient to true north, and that we agree on a path of where we want to go and what the destination is, and maybe worry a little bit less about how fast we can get there. And with that, I'm happy to participate in the discussion and take any questions. And again, I appreciate the opportunity to be here.